Okay, now this is the final expression. This is the total internal force acting on ith particle. Like I can explain it a little bit more. As I already mentioned above, that like my final expression is if I internal is equal to sum over j if ij internal such that I is not equal to j. Now what it means? This is the total internal force acting on ith particle. If I consider my system to be consist of how many particles? Let's say four particles. Okay, this is particle 1, this is 2, this is 3, this is 4. I am not considering the big system, okay, of nth particle, but I consider a small system of 4 particles. Now I consider my this particle number 1. Now on this particle number 1 there is interaction of a force between particle 1 and 2. Okay, like particle 2 exert a force on particle 1. Similarly, there is an interaction between particle 3 and 1. It means there is a force exerted by this particle 3 on 1. Similarly, there is a force exerted by particle 4 on 1. So the total force on particle 1 now will be the force exerted by particle 2 on 1 plus the force exerted by particle 3 on 1 plus the force exerted by the particle 4 on 1. So this is the total force exerted on particle 1, but these are the internal forces. Okay, so I will use int in the superscript. If my system consists of 5 particles, then what will be the situation? If my system consists of 5 particles, let's say 1, 2, 3, 4 and 5, then it means that on this particle 1 there are 4 forces now, internal forces. One is exerted by particle 2 on 1, one is exerted by particle 3 on 1, one is exerted by particle 4 on 1, one is exerted by particle 5 on 1. So the total force on particle 1 is now the total internal force. Okay, force exerted by particle 2 on 1 plus force exerted by particle 3 on 1 plus force exerted by particle 4 on 1, okay, plus force exerted by particle 5th on 1. So now the total forces are how much? 1, 2, 3, 4. Here how much? 1, 2, 3. Now here we use this condition that I is not equal to j. If I say that I is equal to j, what it means? It means that force exerted by particle 1 on particle 1. If I is equal to j, what it means? If I is equal to j, this implies that it represents the force, internal force exerted by particle 1 on particle 1, which is not possible because particle 1 does not exert a force on itself. So we have to exclude this term 1, 1, 2, 2, 3, 3 and so on, because a particle cannot exert a force on itself. Okay, so that's why we use this condition I is not equal to j. So if I expand this equation, if my system consists of n particle, then I can expand this equation by considering the force on first particle. Okay, the total internal force on first particle, which is equal to the force exerted by particle 2 on 1 plus the force exerted by particle 3 on 1 plus up to the force exerted by particle nth particle on 1, if I expand this equation. So we have to exclude this term I is not equal to j. So this is the total internal force acting on ith particle. Now here I will use this sentence that where we use the condition which condition? I is not equal to j. what it means, which means that there is no self interaction of ith particle with itself. Ith particle with itself. This condition basically represents this one, that I is not equal to j means there is no self interaction between of ith particle with itself. Like ith particle does not interact with itself. So it means that the total force acting on ith particle is the total force acting on ith particle is I represented by Fi. The total force acting on ith particle is the force, the external force acting on ith particle plus the internal force, Fi internal. Like this is the total force acting on ith particle. The total force acting on the ith particle is the external force plus internal force. Or I can write it is like this: the total force acting on ith particle is the internal force, the external force acting on the ith particle plus the internal force, and we represent the internal force by this sum over j, okay, Fij internal. But here we will use this condition that I is not equal to j. This is the total force now acting on ith particle. It is the sum of external force plus internal force. Now we know that rate of change of momentum dp over dt is equal to the force. Now if I have to calculate the force on ith particle, then I have to write it as like this: dpi over dt. Rate of change of momentum of ith particle is equal to the force exerted on ith particle. So it means that I can write this equation like this: Fi, which is equal to dpi over dt, which is equal to Fi external plus sum over j Fij internal, such that I is not equal to j. But I represent dpi over dt by pi dot, where pi dot basically represent the time derivative. This basically represents this one, dpi over dt, which is equal to pi dot, which is equal to Fi external plus sum over j Fij internal, such that I is not equal to j. This is another equation. Like for a single particle, we derive this expression like this: dp over dt is equal to force, where the force was only the external force, okay. But here we have a system of particle, so we have the force. The force is now two types: one is the external force and the other one is the internal force, while the rest of the equation is same, because dp over dt is equal to force. But here the force is a sum of two kind of forces: one is the external force and the other one is the internal force. Now here in this expression, I will write the expression again here. The expression is pi dot, okay, which is equal to Fi external sorry plus sum over j Fij internal, such that I is not equal to J. Here the first term on the right hand side, this term, sorry, let's represent the external force, okay? And this is the external force. And this is internal force.